Find unit vectors that are parallel to the diagonals of a parallelogram whose adjacent sides are represented by the vectors a and b. Okay, let us begin. So let's consider a parallelogram with vertices a, b, c, and d. And we're going to represent the side AB as a vector denoted by a vector and the side AD with vector b. Now because ABCD is a parallelogram, the side DC is going to be parallel to AB, so we can also represent it by the vector A, and we can represent the side BC with the vector B. Now what we'll do next is join AC and BD to form the two diagonals of the parallelogram. So here we have the diagonal AC and DB represented in terms of vector. Okay, so let's try to express the AC vector and DB vector in terms of its adjacent sides A and B. We'll start with the triangle ABC. Now in this triangle ABC, we can express AC vector as the sum of AB vector and BC vector. Now AB vector, that's A vector, and BC vector is B vector, which means the diagonal AC vector can be expressed as the sum of the two vectors A and B. Fine, we're going to label this as number 1. Coming to the other triangle, so we're going to consider the triangle ADB. So in triangle ADB, now here we have AD vector added to DB vector, so that will be equals to AB vector. However, we need here DB vector, so DB vector is going to be equals to AB vector minus AD vector. Now what is AB vector? So that's the vector A, and from here we're subtracting AD, so AD is represented by vector B. So that means we can express the other diagonal of the parallelogram DB as the difference of the two vectors A and B. Fine. Now it's given to us the value of A and B, so let's note them down. So using A vector and B vector, now AC vector is going to become A vector added with B vector, so we have I cap plus 2I cap, that's going to give us 3I cap, added to 2j cap plus 4j cap, so that's going to be 6j cap. Then we have 3k cap minus 5k cap, so that's going to give us negative 2k cap. So this is the vector AC. So let's also find out its magnitude. The magnitude of AC vector, that's going to be equals to, we'll take the square root. Underneath the square root, we take the sum of squares. So we'll start with the coefficient of I cap, that's 3, square it and add it to square of coefficient of j, add it to the square of coefficient of k, and that's going to give us a value equals to 7. We can now define the unit vector AC, unit vector along AC vector along the diagonal. That's what we need to find. Now the unit vector along AC vector is going to be defined by take the vector AC and divide by its magnitude. So that's going to give us, we have 3I cap plus 6j cap minus 2k cap divided by 7, or simply put, we have 3 over 7 I cap plus 6 over 7 j cap minus 2 over 7 k cap. So this is going to be the unit vector along the diagonal AC of the parallelogram ABCD. Now let's go to the other diagonal. Now from equation number 2, we can define DB vector. So DB vector is going to be equals to, we need A vector minus B vector. So I cap minus 2j I cap, so that's negative I cap. 2j cap minus 4j cap, so that's negative 2j cap. Then we have 3k cap minus negative 5k cap, so that's going to give us positive 8k cap. Let's find out its magnitude as well. Magnitude of vector DB is going to be equals to the square root of negative 1 squared added to negative 2 squared plus 8 squared. So this is going to be equals to square root of 69. So now we can also find out the unit vector along the diagonal DB, that's going to be equals to 1 over square root of 69 multiplied to negative I cap minus 2j cap plus 8k cap. So we have successfully obtained the unit vector along the two diagonals of the parallelogram. One is the diagonal AC vector and the other is DB vector.